So we're looking at section 5.4, and this is about solving radical equations. So first of all, what is a radical equation? Well, it's just an equation with a radical. I don't think we really need to write anything down about that. Extraneous solutions, though, this is pretty important. Sometimes when we solve a problem, we get solutions that actually do not work. So these are extraneous just means extra solutions that do not make the equation true. Therefore, and these three little dots right there, guys, that means therefore, they are not solutions. So we have to check for these extraneous solutions. Sometimes, especially if we're doing an even root, this is when we normally get these extraneous solutions, as if we have an even root. It usually doesn't happen with odd roots. It's more common with even roots, like square roots, fourth roots, sixth roots. It doesn't usually happen with cube roots, and I'll show you why down here in a minute. So our steps for solving radical equations. The first thing you always want to do is to isolate the radical on one side, if you can. Sometimes you can't do that, but you want to if you can. Then you're going to raise each side of the equation to the same exponent to eliminate the radical and to obtain a linear, quadratic, or other polynomial equation. And then we're just going to solve the resulting equation using all these techniques that we've learned. And this is very important, that you check your solution. Ways we can check it is by plugging it back in, by plugging into the equation, or on the graphing calculator. So we have two ways to do that. Alright, so let's look at how this is going to work then. So if we just have a fairly easy problem, like suppose we have the square root of 4x minus 1 equals 7. We've done problems like this before. How do we undo a square root? Square both sides. So I'm going to square this side, square this side. When I square it, the radical just goes away. 7 squared is 49. We're going to add 1, we get 50. Divide by 4. Well, I'm going to divide by 2 twice. 50 divided by 2 is 25. 25 divided by 2 is 12.5. So that's going to be our answer. If I plug it back in, 4 times 12.5 is 50, minus 1 is 49, square root of 49 is 7, check. Now, one thing I want you to realize, though, is what if we have the square root of 4x minus 1, but this time it's supposed to equal negative 4. Right away, you should recognize that this is not going to work. And that's because the square root of a number is never going to be negative. The square root of a number is always positive. So therefore, this has no real solution. Now, you can try solving this. You can square both sides. If I square both sides, I get 4x minus 1. Negative 4 squared is 16. I add 1. That's 17. I divide by 4, and I get 17 fourths. If I plug back in, though, 4 times 17 fourths is 17, minus 1 is 16. The square root of 16 is not negative 4, it's just 4. So therefore, this is extraneous, and this has no real solution. Okay? What about a cube root? Suppose we have the cube root of, say, 4x minus 1 equals negative 3. Well, this is okay, because a cube root can have a negative answer. The cube root of negative 8 is negative 2. The cube root of negative 27 is negative 3. Cube root of negative 1,000 is negative 10. So therefore, on this problem, I cube both sides. I get 4x minus 1 equals negative 27. I add 1, and I get negative 26. I divide by 4. I'm just going to divide by 2 twice. Divide by 2, I get negative 13. Divide by 2 again, negative 6.5. And that is going to be the solution. 4 times negative 26 fourths is negative 26. Minus 1 is negative 27. Cube root of negative 27 is negative 3. Check. It works. Okay? So not too difficult. All right, let's go over to the next page. Let's look at some that are a little more challenging. 1 and 2 are pretty easy. We just did some problems like those, so we're not going to do those again. Let's skip on down here to number 3. So one of the rules they told us to do is to isolate the radical, get it by itself. So Maya, what would I do first to solve this? Opposite of add 6. So we're going to subtract 6 from both sides. So I'm going to have 1/4 times the 4th root of 2x, subtract 6 is 4. Becky, how do I get rid of the 1/4? Right, so if I multiply by 4, I'm going to have the 4th root of 2x equals 16. So now I have to take both of these and raise it to the 4th power. And so I'm going to have 2x, and then I'm just going to have to get my calculator out to be 16 to the 4th. So 65,536, 65,536, divide that by 2, and I get 32,768. And I should plug it back in. Well, 2 times it is going to give me back to this number. The 4th root of that number is 16. 1/4 of 16 is going to be 4, plus 6 is going to give us 10. So yes, it works. All right, let's look at this one. First thing we're going to do is divide by 2. Cube both sides. Add your 5 and divide by 13. X is 10. Plug it back in. 13 times 10 is 130, minus 5 is 125. Cube root of 125 is 5, times 2 is 10. Okay? All right, now let's do one a little more challenging. Look at number 5. If possible, we would like to isolate the radical. It's already isolated, though. So we just have to go ahead and start. We have to square both sides. The only reason this one is tricky is because of squaring x minus 7. A lot of people say, oh, that's just x squared minus 49, or it's x squared plus 49. That's wrong. If I have to square x minus 7, it's x minus 7 times x minus 7. This is easy to square. It's just x minus 5. But over here, I have to FOIL this. This is x squared minus 14x plus 49 equals x minus 5. Now I want to get this all set equal to 0. So I have x squared minus 15x plus 54 equals 0. Whenever I have a quadratic equation, I want to try to solve it by factoring. So I'm going to put my x and my x. What are numbers that multiply to be 54 and add to be 15? 9 and 6 is correct. They're both negatives. And so now I set each one of these equal to 0. And so x equals 9 and x equals 6. But notice, I had a square root. I definitely want to check this. Plug it in. 9 minus 7 is 2. 9 minus 5 is 4. Square root of 4 is 2. That's fine. That worked. Check 6. 6 minus 7 is negative 1. 6 minus 5 is 1. The square root of 1 is not negative 1. It's just 1. Therefore, this is an extraneous solution. 9 is the only one that works. Extraneous, and that's the actual solution. Questions there? All right, we're going to skip. Well, I just want to show you the first step. We're not going to go all the way through this one. But on this one, if I have a cube root, I just want to cube both sides. So this is going to be 486 minus 27x to the third. What's 3x quantity squared cubed going to be? Right, this is just 27x to the third. That's all you'd have to do with it. And then you would just solve it. We're not going to finish that though, it's just the same as the other ones. Okay, let's look at number 7. It's a little bit different. Number 7, we want to look and see if we can isolate the radical. But if we divide by 4, it's just going to make this side worse to work with. So I don't want to eliminate the 4. I'm just going to have to square both sides. And I wanted to show you this one to show you what you do under this circumstance where you have a 4 and a radical. Well, 4 squared is just 16. Radical x plus 1 squared is just x plus 1. Over here, we're going to have to square that whole thing out. Do you know what that's going to be if you square that out? People are whispering it. It is x squared plus 2x plus 1. So now I'm going to have 16x plus 16 equals this. So I'm going to have to set it equal to 0 anytime I have a quadratic. So I'm going to have to subtract 16x, that's negative 14x. 1 minus 16 is going to be minus 15. So now I'm going to factor this. It's going to be a negative 15 and a positive 1. So then x is going to have to be 15 and negative 1. Now, I'm going to show you a different way to check. Instead of substituting in, another way you can check your answer. I can put this into my y sub 1. So I want to do 4 radical x plus 1. And I want to put in just x plus 1. What I'm going to do is a zoom 6, and I want to see how many places they intersect at. So there's the first one, and there's the second one. I'm going to have to extend my window a little bit to be able to see further. There's the first one. There's the second one. Are they intersecting there at negative 1? It didn't look like they were, did it? It looks like they might be intersecting there. So I do second calculate the point of intersection. I want to be close to that point. Enter, enter, enter. It tells me at 15, that's where they're intersecting. See, look, I can look at my table of values. When x is negative 1, they would have to have the same answer for it to be a solution. Oh, looks like they do. Okay, so maybe negative 1 is a solution. Let's try substituting it in. Negative 1 plus 1 is 0. Square root of 0 is 0 times 4 is 0. Negative 1 plus 1 is 0. So yes, they actually are both solutions there. They both were fine. That's why I wanted to show you this one, though. Remember when I was on this screen? They don't really look like they intersect there. But remember how I told you the calculator can be a little off? It thinks that's a vertical line, so it kind of stops graphing it. But if I look at my table, I can see that it actually is a point on the graph, so therefore it is going to be a solution. All right, let's try this one. What do you think we'd want to do first here? We don't want to square both sides right now. It's going to be really tough to do, so what should we do? We want to take this over to the other side, guys. Just take that over. So we would have the square root of 2x plus 2. If I take this over to the other side, it's going to be plus radical x plus 1. Or plus 3, rather. Radical x plus 1. Now I can square both sides. What happens when I square that? What's it just going to be? Dominic, what's it going to be if I square that? Right? And then what's 3 squared, Dominic? And then here I would just have x plus 1. So then we're going to have 2x plus 2 equals 9x plus 9. So I'm going to take this over here. So subtract 2x and you get 7x. Subtract 9, you get negative 7. Then we get x equals negative 1. Let's see if that really works. 2 times negative 1 is negative 2, plus 2 is 0. Negative 1 plus 1 is 0. 0 times anything, it works. That's our solution. All right, we're just going to do one more, and that's number 10. This is the hardest one on here. If you look at this problem, we have to square both sides. Okay? Here's why I want you to watch this, is we're going to have to square both sides a couple of times. When I square this side's easy to square. But this side, I have to actually write it out twice. So when I write it out twice, now I can multiply it. This times this is just going to be x plus 7. The outers are going to give me a 2 radical x plus 7. The inners are going to give me another 2 radical x plus 7. The last times the last is 4. So we would have this. So now I want to combine any like terms I have on each side. So here I've got an x, and then I have 7 plus 4, that's 11, and then these are both like terms. And so that's going to give me plus 4 radical x plus 7. And that's equal to 3 minus x. Now we want to, again, try to get that radical by itself. So to get the radical by itself, I'm going to have to subtract the x and subtract the 11. I'm going to have to come over here now. So we're going to have 4 radical x plus 7 equals 3 minus 11 is negative 8 minus 2x. Now, if I divide by 4, I'm going to get a fraction with this x term. So I don't really want to divide by 4. I can keep my numbers a little bit smaller, though. What can I divide both sides by instead of 4 so I don't get that fraction? Just divide by 2. So I'm going to have 2 radical x plus 7 equals negative 4 minus x. Again, we have to get rid of the radical to solve it. So I'm now going to have to square both sides again. Squaring this, 2 squared is 4. Radical x plus 7 squared is just x plus 7. To square this, I have to write it out twice. Negative 4 minus x times negative 4 minus x. That's how I square it. Negative 4 times negative 4 is 16. The outers give me positive 4x. The inners give me positive 4x. That's positive 8x. Negative x times negative x is positive x squared. Again, doing a little more, 4x plus 28 equals 16 plus 8x plus x squared. I want to get this set equal to 0, so I'm going to have my x squared. I'm going to put that first. I have 8x minus 4x. That's 4x. I have 16 minus 28. That's going to be minus 12. Does this factor? Are there numbers that multiply to be 12 and subtract to be 4? What are they, guys? 6 and 2. So it's going to be x plus 6 and x minus 2 equals 0. And what are the final solutions then? Negative 6 and 2. We might want to check them by plugging them in. Mine is so written on, I can't even really tell. So instead, I'm just going to do it on the calculator. Radical x plus 7 plus 2 is my first equation. Radical 3 minus x is the second equation. I want to see if they do intersect at negative 6 and 2. Oh, well, what is it then, guys? What's the only place they intersect? Negative 6. 2 is extraneous. They definitely do not have the same values when x equals 2. See how that does not work? They're not equal there. But at negative 6, they are equal there. So 2 is extraneous. Negative 6 is the only solution. If you substituted them back in, you would have seen the same thing. All right, so one more time on this one. We had to square both sides a couple of times here. So we even do it 3 times. Let's see, 1,